the way to do a fraction exponent is you take the denominator and it is the index of the root. So it goes on the outside of the root. The x and the a go inside the root as x to the a power. A variation on that is that you can float that a outside the root if you want to, and that works just as well. So the denominator is the index of the root, and the a stays on the x as x to the a power. Or the a can be used as an exponent for the whole thing. So y to the 1/2 would be the square root of y to the first power. Well, we don't normally write either of those numbers in that situation, the 2 index or the 1 exponent, so that would be written as root y. So a 1/2 power is a square root. How would I write c to the 2/3 power? Anyone? The cube root of c squared. That's the first thing we have to get. The denominator is the index, and everything else is goes inside. Or I'll add to this last one, if it was an advantage to you, you could have also written it like this. No. Okay, so let's continue on. We're going to do these two problems, and since we don't have a calculator, we're going to have to figure out a way to do this without a calculator. 32 to the 2/5 power. So we're going to rewrite this as a root. How would I write 32 to the 2/5 power as a root? Laura.
You'd put the little 5.
You'd put the little 5
by the root.
By the root.
Like that. And then you do 32 squared under it.
Okay. Well, do we know what 32 squared is in our head?
164.
No, that's 32 times 2. So I don't know what it is in my head. So what I'm going to do, one thing I do know though, is I know the 5th root of 32. The 5th root of 32 is 2 squared, which is 4. So we found a way to do this one without needing a calculator. I want you to do the same process. I want you to try to do the same process on the bottom. So I've got the cube root of 64 squared. Don't know what 64 squared is, so I'm going to move the 2 out. And then I'm hoping that the cube root of 64 works out, which it does. I know in my experience that that is 4. So my answer is 16. Manageable so far?
I don't understand that.
Okay.
I didn't think it was.
Now we're going to add another little wrinkle. 49 to the negative 1/2. Let's try to remember how we dealt with negative exponents. Does anybody remember? Put it on the bottom. Remember, we had upset children, and so we moved them to the basement. So we're going to do the same thing here. So 49 to the negative 1/2 is going to move to the basement and become 49 to the positive 1/2. And as I told you at the beginning, a 1/2 power means square root. So what does the bottom equal?
7.
49 to the 1/2 is equal to the square root of 49, which is 7. So on the bottom we have x to the negative 2/3. I'm going to move the x to the negative 2/3 down to the bottom. Becomes positive 2/3. How do you write x to the 2/3 as a radical or root? Does anybody know?
3 square root x cubed.
Squared. Cube root of x squared. Now we have a root on the bottom, which we can't have. So how do you get rid of a root on the bottom last week? We have to throw something in that will give us no lonelies.
Square root of x.
We need one more x to make triple x's. Okay? We have 2, we need 3. So we have to throw in another x. See how everything's coming together? Negative exponents, rational exponents, getting the root off the bottom, everything works together. We might learn them separately, but they all work together. So the top becomes cube root of x. Bottom becomes cube root of x cubed, which is just x. Let's continue. I want you to do this one. C to the negative 1/2. Okay, we're going to move the 1/2 to the bottom. We're going to change it to a square root. We have a lonely c. We need another one to make 2. So the correct answer is the square root of c over c. Now what we're going to do is we're going to go backwards. We're going to turn a root into a rational exponent. So the first one is a baby problem. It's real basic. In fact, we did one close to this on the first slide. That's y to the first. So writing that using rational exponents would just be y to the 1/3. Everybody see that? Making that transition? When they get a little more complicated is when the inside is not broken down. If the inside can be written as something to a power, if a tree can be made of the inside, you need to make it. All right, so 8 is 2 to the 3rd. So before you write it as a rational exponent, you need to change the inside to its most broken down state. 2 to the 3rd. Then write your rational exponent, which would be what? It would be 2 to the 3/6 power. And then tell me more. It'd be 2 to the 1/2. So the 6th root of 8 is the same exact thing as the square root of 2. They're the same number. I want you to try a couple. I want you to try the 4th root of 25. 4th root of 25 is equal to the 4th root of 5 squared, which is 5 to the 2/4, which is 5 to the 1/2. Let's try one more like this. Does anybody have any questions so far? Last one of this kind before we move on. 6th root of 27. 6th root of 27 is the 6th root of 3 to the 3rd, which is 3 to the 3/6, which is 3 to the 1/2 power. All right, now we can do the same thing, only we can add more than one term under the root. There could be 4 or 5 terms under the root. You just go down the line and do each one separately. So for example, in the first one we have the sixth root of 4x to the fourth. 4 is 2 squared. And so each of those, written separately using rational exponents, would be 2 to the 2 sixths, x to the 4 sixths, and then each of those reduces. So that doesn't make the problem any more conceptually difficult. It's just longer. So don't be afraid. I want you to try the second one and see if you can fight through the conundrum that you might find. It's not really a conundrum, just a little bit of a did you see it type thing. So you maybe got that far and you maybe wrote 2 to the 4 thirds, y to the 4 thirds and stopped, which is okay. But what you should have noticed is you actually have enough here to circle 3 of a kind. And take them out. Two y cube root of 2y, and then if you were going to write that using rational exponents, you would just write 2 to the 1/3, y to the 1/3 with the 2y on the outside. Now, you have to know the difference in what I am asking. If I ask you to write an answer using rational expressions, I'm asking for rational exponents. I have it written wrong there. It's rational exponents. I'm asking for that. If I'm asking for radical expressions, I guess we could keep it as expressions. Radical expressions, it would be that one. You have to know the difference between rational exponents and radical. Rational and radical. Okay. And you take stuff out when you can. We had enough 2's and enough y's to take out a group. Let's keep going. Now we're going to do some problems that the first one we could have done all along. Yes, ma'am. The first one up here we could have done before we knew what rational exponents was. Now that we know rational exponents, though, we can do ones like this on the bottom that we could not have done before. The thing on the bottom that's screwed up is the fact that the index values are different. Now we can do it with rational exponents. Here's how we do it. I'm going to show you the top one, then I'm going to let you try that one on the bottom. So what we're going to do on the top is we are going to write the top and the bottom, numerator, denominator, using rational exponents, like I've shown you today. So 16 is 2 to the 4th. And cube root of 2 is the cube root of 2. All right. The cube root of 2 to the 4th is 2 to the 4 thirds. And the cube root of 2 is 2 to the 1/3. Now, how do you deal with a problem where you have the same base and you're dividing? Here's an example of one that I'm talking about. How do I deal with x to the 7th over x to the 4th? Subtract the exponents. So that's what I'm going to do up there. What is 4 thirds minus 1/3? 3 thirds, commonly referred to as 1. So that answer is 2. Don't need a calculator or anything. You could use one, but where's the fun? We're not taking 2 divided by 2. When you subtract the exponents, you're just left with the same base to that power. If I do x to the 7th divided by x to the 4th, it's x to that power. So this is 2 to the first power. I want you to try the second one using that same skill. Using a common denominator of 12, I would multiply the first one by 3 to get 15 twelfths. And I would multiply the second fraction by 4 to get 4 twelfths. Remember that from back in the day?
Oh, yes.
So now I can subtract the fractions and get an answer of 11 twelfths. So when I subtract the exponents, I get 2 and 11, or 2 to the 11 twelfths power. No. That would be the answer using rational exponents. Now, what if I asked you to give me the answer as a radical? What would you write?
That one.
No, the answer as a radical. The 12th root of 2 to the 11th.